Negative exponents. In this video, you'll learn how to describe the meaning of a negative exponent in equations that represent exponential decay. You'll also learn how to write and graph an equation that represents exponential decay to solve problems. Exponents represent multiplication patterns. Negative exponents indicate going backwards in time. Negative exponents don't make numbers negative, they represent reciprocals. So if we have an expression with a base of a and an exponent of negative n, then we can write this as a reciprocal so that the negative n becomes positive n. So if we have the value 5 to the negative first power, then we can write this as 1 over 5 to the positive 1. And this will give us 1 over 5. Or if we had 3 to the negative second power, we can write this as 1 over 3 to the positive second power. 3 squared is equal to 9, so this is equivalent to 1/9. Let's look at some real-world problems where we'll see negative exponents. If bacteria doubles every hour, the function is y equals 100 times 2 to the x power. We're going to fill out this table where we're given x values of 0, 1, and negative 1, and we'll interpret what the x value means and then find the y from the function. If x is 0, this tells us that this is our initial measurement. To find y, we'll replace x with the 0 that we were given. Anything to the 0 power always gives us 1, so we have 100 times 1, which gives us 100. Now let's look at when x equals 1. This tells us this is 1 hour after measuring. So to find y, we'll replace x with 1, and 2 to the first power is still just 2. Multiplying will give us a value of 200. Now let's look at it when x is negative 1. This tells us that we're looking at 1 hour before measuring. So this time we'll replace x with negative 1, and this will give us 1 over 2 to the positive 1, which is equivalent to 1/2. Multiplying 1/2 times 100 gives us the value of 50. Here's another one. A marine biologist estimates that a structure of coral has a volume of 1,200 centimeters cubed and that its volume doubles each year. Let's start by making an exponential function from this situation. We know that the volume started at 1,200 centimeters cubed, so a will be replaced with 1,200. We know that its volume is doubling every year, so b will be replaced with 2. Now we want to know what is the volume if x equals negative 2, and what does this mean in this situation? So we'll take our function and replace x with negative 2. This will give us a reciprocal of 1 over 2 to the second power, which is equal to 1 over 4. Multiplying this by our original 1,200 gives us a value of 300. So this tells us that 2 years before the initial measurement, the volume was 300 centimeters cubed. In our next example, a forest fire has been burning for several days. The burned area in acres is given by the equation y equals 4,800 times 2 to the x power, where d is the number of days since the fire was measured. So we'll fill out this table with the given d values. If d is 0, then we just have our initial measurement of 4,800. If d is negative 1, then our x value becomes negative 1. So instead of doubling, we're going to be cutting it in half. So half of 4,800 would give us 2,400. And then when d is negative 2, we'll cut this in half again, which gives us 1,200. And then we'll repeat this step for d equals negative 3, which gives us 600. Now we have d is equal to negative 5, so we skipped negative 4, so we'll have to cut this one in half twice. This will give us 150 after cutting it in half twice. Let's look at another one. The value of a home in 2015 was $400,000. Its value has been doubling each decade. So we're going to use this exponential function where v represents the value of the home and d represents the number of decades. We know that the home value in 2015 was $400,000. So we'll replace a with 400,000. We also know that the value has been doubling each decade. So we'll replace b with 2. What is v when d equals negative 1, and what does this value mean? So we'll take our function and we'll replace d with negative 1. This gives us a reciprocal of 1 over 2 to the positive 1 power, which is the same as 1/2. So multiplying 1/2 times 400,000 gives us a value of 200,000. So this tells us that the value of the home in 2005 was $200,000. What is v when d equals -3, and what does this value mean? So we'll take our function and replace d with -3 this time, which will give us 1 over 2 to the positive 3. And 2 to the third power gives us a value of 8. Multiplying 1/8 times 400,000 will give us a value of 50,000. So the value of the home in 1985, which was 3 decades ago, was $50,000. Now we have a fish population can be represented by the equation p equals 800 times 0.5 to the t power, where t is the time in years since the beginning of 2015. We want to know what was the fish population at the beginning of 2012. So we'll take the function they gave us, and since we want to know the population in 2012, which was 3 years ago, we'll replace t with -3. 0.5 to the -3rd power gives us the reciprocal of 1 over 0.5 to the positive third. And this simplifies to 1 over 0.125. If we divide 1 by the 0.125, we'll get a value of 8, and then multiplying that by the 800 will give us a population of 6,400. Now let's recap what we've learned. A negative exponent doesn't represent a negative value, but a reciprocal. Negative exponents in exponential functions represent time intervals before the initial value is measured.